Before we get into power to a power with exponents, we're just going to review multiplying. Simplify to a single power of 6. I'm going to give this 6 an exponent of 1 because it's missing the power. And then appropriate work would start with writing down the original problem. So I'm going to write 6 to the power of 1 multiplied by 6 to the power of 6. Now to show the operation between the exponents, when we have the same base, notice base 6 and base 6, we actually add the exponents together. So I would write base 6 and then my power would be 1 plus 6. And then 6 to the power of 1 plus the power of 6 would simplify to 6 to the power of 7, and we'll box that. Okay, dividing is real similar to multiplying. Notice that when we multiply, we add the exponents. So when we divide, we're actually going to subtract. I'm going to start by writing the original problem. So I've got 3 to the power of 5. Divide by 3 to the power of 1. I'm going to give it an exponent of 1 there. And when we have the same base, base 3, when we're dividing, we actually subtract the exponents. So I'll write the number from the top, which is 3 to the power of 5, subtract the power of 1. So 3 to the power of 5 minus a power of 1 is going to simplify to 3 to the power of 4, and that's how you show appropriate work. All right, today's lesson now. We want to simplify to a single power of 3. So we have base 3, we have an exponent of 2, and an exponent of 4 here. So just a quick reminder, we went over some vocab from yesterday's lesson. The number that's listed here, this big number right here, that's considered our base. And then the little number 2 and the little number 4 here, those are actually considered exponents or powers. So I'm just going to switch over to green and I'm going to show you what this would look like if we were to put it in expanded form. So let's deal with it inside the parentheses. I would have 3 squared would stand for 3 times 3. And then this 4 on the outside means that I'm going to have 4 different parentheses. So there's 1, 2, 3, and 4. And all I have to do is put whatever's on the inside of it. So I'm going to put 3 times 3. And 3 times 3, and 3 times 3. So 3 squared is really 3 times 3, and then I should have 4 groups of parentheses, which I do. And of course, you could simplify it, just go 1, 2, 3, 4, 5, 6, 7, 8. That's going to be 3 to the power of 8. Now, we want to go ahead and show some appropriate work for this. And what I'm going to do is switch over to blue. I'm going to rewrite the original problem. And the original problem is going to be 3 squared inside parentheses. And then it has a power or an exponent of 4 on the outside. Well, if we look over here, what would I do with the 2 and the 4 to ultimately get 8? Most people are going to say, well, you'd multiply 2 times 4 to get 8. That makes sense to me, and that's actually what the operation is. So after we write down the original problem, show the operation between the exponents. So I'm going to write base 3, exponent of 2, multiplied by 4. So I would have 3 to the power of 8, and we'll box that, and that's our final answer. Notice 3 to the power of 8 matches the expanded form, but what we did in blue is the appropriate work. So 3 to the power of 8. All right. Let's try and hit you up with something that's just a little bit different. I don't think you'll get these on your homework, but I wanted to go over it. So this is going to be 5 inside of parentheses. I'm going to give it a power of 1. Remember, if you ever see a base without an exponent, you can always give it a 1. And so what this means that I'm going to have 3 sets of parentheses because there's a 3 on the outside. So my 3 sets of parentheses. And then on the inside, I would have a 5 here, a 5 here, and a 5 here. So we'd have 1, 2, 3. So that's going to be 5 to the power of 3. Switching over to blue and showing our appropriate work, we'll start by writing down the original problem. So I'm going to write 5 to the power of 1 in parentheses with the power of 3 on the outside. Well, what would I do to 1 and 3 in order to get 3? Well, you'd have to multiply. 1 times 3 is 3, and that's the rule for it. So I'm going to write base 5, 1 multiplied by 3. And that's my appropriate work. So the operation in this case that we're saying right here, it's actually multiplied. And whenever you have a power inside and outside, you just multiply them together. So that's going to give us 5 to the power of 3, which matches that. I'm going to box that and put it in there. All right, let's go do one more. So now I have 2 to the 3rd degree, or 2 to the power of 3 on the inside, and I don't have a power on the outside. Well, guess what you can put on the outside then? That's right, you can put a power of 1. Although that should be in green, because that's what I've been doing so far. All right, switching over to green, I'm going to give it a power of 1. And I'm going to do what's inside the parentheses first. And I should have 3 2's. So I'm going to put 2 times 2 times 2. And I only drew one group of parentheses because this stated there should be only one group. So that's going to be 1, 2, 3. That's going to be 2 to the power of 3. Similarly, what would you do to 3 and 1 to get 3? Well, you'd go 3 times 1, which is kind of the same as what we did over here, except it was the inverse. It was 1 times 3. So here we go. Let me get rid of this right there. Okay, so switching over to blue now for our appropriate work. I'm going to go ahead and write the original problem, just like we did right there. I'm going to put 2 to the power of 3, parentheses, 1 on the outside. To show the operation between the exponents, I would write 2 to the power of 3 multiplied by the power on the outside, which is a 1, and then 2 to the power of 3 times the power of 1 is going to give us 2 to the power of 3, which is the same thing we had here, and this is our appropriate work. And that's pretty much it. So we'll summarize yesterday and today's lesson by stating that when we're multiplying with exponents with the same base, you add the exponents. When you're dividing exponents with the same base, you subtract the exponents. And then we learned today that when you're dealing with power of a power with exponents with the same base, all right, you would go ahead and multiply the exponents. And that's it. Thanks for viewing, and thanks for showing appropriate work.